Experiment 1. Synthesis and analysis of copper coordination compounds.
Coordination compound or complex consists of central metal atom, Lewis acid, and ligand, Lewis space, which can donate a pair or more electron to the central atom through dative covalent bond.
When an ammonia is added to the concentrated copper sulfate solution, there were 4 main spectra that exist in the mixture, which were hexacryptopyr-2-ion, NH3 molecule, sulfate ion, and water molecules.
There are 2 types of analysis, which were gravimetric analysis, X mole of Pb2 plus X mole of SO40 to form X mole of SO4, and volumetric analysis, Y mole of NH3 plus Y mole of H plus 4 Y mole of NH4 plus.
Spectrophotometric analysis, carried out with wavelength of 645 nanometers to determine the presence of copper ions. The wavelength was chosen because it was the range wavelength of orange color, which is complementary to blue color. It will absorb orange color and will transmit blue color. The concentration of copper ion is determined from the calibration graph of absorbance against concentration of standard copper solution.
The objective of this experiment is to synthesize and determine the molecular formula of a copper complex having the general formula CuXNH3YSO4ZaH2O by using 3 different techniques, which are gravimetric analysis on copper, volumetric analysis on NH3, and spectrophotometric analysis on copper ions.
The procedure of this experiment is divided into 2 parts, which is part A, the synthesis, and part B, the analysis. 10 grams of copper sulfate pentahydrate is placed in a beaker, and it was dissolved with 10 until 15 ml of deionized water, and 20 ml of concentrated NH3 was added. After that, 10 ml of ethanol 95% is added dropwise. Meanwhile, in another beaker, 10 ml of concentrated aqueous NH3 and 15 ml ethanol 90% is mixed up. Wash glass is used to cover the beaker. The apparatus for vacuum filtration was prepared, and the resulting copper compound crystal was filtered. The crystal was washed with 10 ml of ammonia ethanol solution twice, 10 ml of ethanol 95% twice, and lastly with 10 ml of acetone twice. After that, the crystal was collected in the beaker and being covered with filter paper. It was going to be used in part B. 2 samples of crystals from part A was weighed about 0.9 until 1.1 gram. Each of the sample was analyzed by the following steps. Firstly, the sample was dissolved in 10 ml of nitric acid 6 mol, then 5 until 6 ml of lead acetate was added dropwise until precipitation complete. After that, the compound was filtered by using gravitational filtration. The beaker was rinsed with 5 ml of distilled water and finally with 10 ml of acetone. Then, the solid was carefully being taken out and placed on a white wash glass. Then, it was dried in an oven at 80 degrees Celsius. The weight of precipitate was recorded. The amount of ammonia in our compound can be determined by acid-base titration method. Firstly, 2 samples of crystal from part A was weighed about 1.0 gram. Each of the sample was analyzed with the following steps. The sample was dissolved with 30 ml of distilled water in an aluminium flask. As soon as possible, 10 drops of methyl orange indicator was added into the solutions, and it was titrated with HCl 0.5 mol. The color will change from dark blue to reddish orange at the end point. Then the titration result was recorded. 6 dry and clean test tube was labeled from 1 until 6. A series of standard calibration solution and sample solution that are going to be shown at the end of this section was prepared. Test tube 1 until 4 was used for calibration. The absorbance for each standard solution and sample was measured at 645 nanometer. Then, a calibration plot was prepared by plotting absorbance of standard solution as a function of concentration. From the calibration plot, we determine the concentration of copper 2+ in our sample, which is for test tube 5 and 6. In this experiment, we have synthesized and determined the molecular formula for a copper complex having the general formula. Firstly, hydrated copper sulfate was weighed and added to a clean and dry beaker. The solid was added with ionized water to dissolve it. concentrated ammonia solution was added dropwise to prevent localized supersaturation from occur. The adding of ammonia solution was carried out in fume hood because concentrated ammonia is easily vaporized and the reaction released upon use smell. The reason of not using dilute ammonia solution to add into the solution is because the water molecule will compete with ammonia molecule to bond with copper ion. Along the additions of concentrated ammonia, the solution was stirred to ensure that all the solids have dissolved completely. %95 ethanol was added dropwise into the solution while stirring continuously. To induce the growing of the crystal, the solution is left to cool to room temperature. 95% ethanol played the role of precipitating agent because the compound form was soluble in water but insoluble in ethanol. As the formations of bond will release heat energy, this is an exothermic process. Filtration of crystal foam was done through vacuum filtration. Firstly, the crystal was washed with 10 ml of ammonia ethanol solution twice so that the excess NH3 solutions can be removed. To remove excess water in the crystal, it was washed twice with 10 ml of ethanol 95%. Lastly, acetone was used to wash the crystal twice to speed up the drying process due to the properties of acetone, which has a low boiling point that is easily vaporized. The crystal was then collected in a beaker, weighed and labeled. Filter paper was used to cover the beaker and keep for the following experiment, which is the analysis of the compound. For gravimetric analysis of sulfate ion, 0.9 gram to 1.1 gram of crystal was weighed to use as two samples. Nitric acid was then added into both of the samples to dissolve the crystal. Then, lead acetate 1 molar was added dropwise into the solution until the completion of precipitation. This is due to lead acetate solution can be used to determine the existence of sulfate ion. The ratio between lead acetate and sulfate ion produces lead sulfate, which is a white precipitate. From the white precipitate observed, we can deduce that SO4 to minus were located at the outer surface of coordinate compound as it can be ionized, so it was not directly bonded to the central metal ion. The precipitate obtained was filtered through gravitational filtration and the filter paper used was wet. The beaker was rinsed with little water to recover all the precipitate. Then acetone was used to wash the precipitate to remove excess water. The filter paper along with the solid recovered was taken carefully to avoid dropping of the precipitate and it was placed on wash glass and dried it in oven at 80 degrees. When the solid was dried completely, the precipitate was weighed together with the filter paper, thus the sulfate ion can be determined through gravimetric analysis. For volumetric analysis on NH3, to determine the quantity of ammonia in the compound, volumetric analysis is used. The crystal sample was weighed twice for 1.0 gram. It was dissolved with 30 ml of distilled water in an aluminium flask. Then about 10 drops of methyl orange indicator were added into the solution as soon as possible. Titration was done by using 0.5 molar HCl and the color changed from dark blue to reddish orange at the end point. To obtain the mean value or volume of HCl added, the titration was repeated twice. The ratios of acid and ammonia are as below. For spectrophotometric analysis of CO2+, to determine the compositions of copper ion CO2+ in the copper coordination compounds, spectrophotometric analysis is used. Then ultraviolet visible molecular absorption spectrometry was used to measure the absorbance for standard copper solutions and sample solution. Quantitative analysis can be done by using the spectrometry but not quantitative analysis. To carry out the UV molecular absorption spectrometry test, several precaution steps should be taken, such as the dropper that was used to transfer the sample must be rinsed with distilled water before use to avoid the contamination of concentration from other standard solutions. Besides, the cell must be rinsed with distilled water every time before using it. The presence of contaminants which will affect the reading. From the three types of analysis, the ratio of CO2+ and H3SO4 2- and H2O were determined. The linear calibration curve of the standard copper gives the equations. From the equation, the concentration of the samples of copper complex can be determined. From the result obtained, the percentage of CO2+, SO4 2- and NH3 in the copper complex are 30.25%, 42.60% and 39.82% respectively. We have obtained a negative value of negative 2.33% for H2O molecule. We deduce that this percentage negative occur due to the SO4 2- ion, which has a very high percentage weight. This is probably due to the crystal form are not dry completely in the oven when the weight process was done. In fact, we have known that we should repeat the heating, cooling and weight process until a constant weight has obtained. By assuming the ratio of H2O molecule is 1 in the copper complex. The empirical formula was, which was CuNH3 for 2+ cation complex. This ion has the structure of square planar, 3 to the unpaired electron in its 3d orbital. The complex is a paramagnetic compound. The electron configuration of copper are shown below. Thus, the complex of copper compound has a shape of square planar.
That's all from us.
Thank you. Bye.